students. In our first video of nuclear physics, we got what is nuclear physics, what are the isotopes, isobar and isoton, and also about radioactivity and radioactive substance. At last, we got in that video how Rutherford got three types of radiation. One is alpha particle or alpha radiation. Beam of alpha particle is called alpha radiation, beta radiation or beta particle, and gamma radiation. In this video, we are going to discuss about their characteristics, their nature, and when a nucleus emit alpha or beta and gamma, what the different changes will occur in the inside the nucleus. So let's start our nuclear physics part 2. So first in this video, we are going to discuss now about characteristics of alpha particle. Alpha particle deviate towards negative side, since it is having positive charge. So what are the more properties, more characteristics of this alpha particle we'll discuss in this part. First one, if we look here, alpha particle consists of 2 proton and 2 neutron. That means inside the nucleus it is having 2 proton, 2 neutron, means it's having a mass number 4. And because 2 proton it is having, that means it is having 2 positive charge. Means it is similar with the atomic structure of helium. So that means alpha particle is a doubly ionized helium atom, which is having mass number 4, atomic number 2. Second point, if we look here, the mass of alpha particle is roughly 4 times the mass of a proton. Means it is a heavy particle. Because it is heavy, so it will deviate less from its original path. And approx mass is 6.68 into 10 to the power minus 27 kg, and it is having the charge twice the charge of a proton, because it is having 2 proton inside its nucleus, and as we know, the charge of 1 proton is plus 1.67 into 10 to the power minus 19 coulomb. Third one, the speed of alpha particle is in the order 10 to the power 7 meter per second. Means alpha particle speed is less in compared to other radiation because it's heavy particle. And here we can see alpha particle strongly ionize the gas through which it passes. Ionize. Ionize means when a neutral substance changes to ion, the process is called ionization. Because alpha particle has doubly charged positive ion, so easily it can change a neutral gaseous atom into ion. So it's having ionizing power very high. But because it's a heavy particle, so it cannot able to pass inside any matter. Means its penetrating power is very low. And because alpha particle are having positive charge, so they are deflected by the electric and magnetic field, and they will move towards negative plate in an electric field. And here we can see this effective photographic plate. If you look the Rutherford model, last Rutherford kept a photographic plate, and by the effect on photographic plate, Rutherford got the conclusion that there are 3 types of radiation coming out from a radioactive substance. Means alpha particle affect a photographic plate, and also it causes fluorescence on strike to fluorescent material. Fluorescence, the property by which any substance or a substance emit radiation. When radiation hit to it, when will strike radiation to that particular, when will strike different rays to that particular material, it emit light. That is fluorescence. The property is called fluorescence. And that type of substance shows the property of fluorescence, which is called fluorescent material. Means a particle called fluorescence means because of this alpha particle, or when alpha particle hit to such type of substance like zinc sulfide, they emit light. And here we can see alpha particle cause strong biological damage. Means alpha particle when it hit to the human skin or animal skin, it gives different effect or harmful effect to the body, because it is having penetrating power low, so only it can affect to the upper surface of the body. And alpha particle gets scattered when passed to gold foil. This one in Rutherford model also, gold foil, when Rutherford used and passed the alpha particle in chemistry, you will get that it is scattered to and got about the nucleus. We'll look discover the nucleus time. So alpha particle can scatter from its original path. So alpha particle are having all these characteristics. Now at the time, it is for the beta particle. In beta particle, we'll get different characteristics of beta particle. First one, if we look here, beta particle is a negatively charged ion. Simply we can say beta particle, the fast moving electron emitted from the nucleus. Inside the nucleus, when nuclear change occurs, beta particle of fast moving electron comes out. That is the beta particle. And beta particle having only one electron. That means its mass nearly equal to the mass of one proton, one electron. And charge of one electron, which is minus 1.67 into 10 to the power minus 19 coulomb. Beta particle having speed more in compared to alpha. Alpha particle in the order 10 to the power 7 meter per second, but beta particle in the order 10 to the power 8 meter per second. But its speed is less than the speed of light in air or vacuum. And if we look beta particle 1, beta particle also ionize the gas through which it passes because it is having negatively charged. And if we look the Rutherford arrangement, beta particles are deviating more in compared to alpha because beta particle is having mass less, alpha particle having mass more. Beta particle ionize the gas as alpha particle having positive charge is ionizing the gas, and beta particle having negative charge, so it is also ionizing the gas. But if we compare the ionizing power, then beta particle having less ionizing power in compared to alpha, and beta particle also deflect by electric and magnetic field because beta particle having negative charge, so it always attracted toward the positive plate because the electrostatic force of attraction. And as alpha particle affect to the photographic plate, beta particle also affect to the photographic plate. Alpha particle time also we got it create or it cause fluorescence on a fluorescent material. Here also beta particle when hit to a fluorescent substance like sulfide, it emit light. So it is also having the property of fluorescence. And next one, beta particle cause more biological damage than alpha because beta particle is having massless because it is a lighter particle in compared to alpha, so it is having penetrating power high, so it can go more deep inside. Because of that, it gives more harmful effect in compared to alpha. Now next in our discussion, we will discuss about the third one because in Rutherford model, if we look, one it was going towards negative part, one it was coming towards positive part, another one going straight, which is having no charge. So here we will discuss about the third one, which is having no charge, which is gamma rays or gamma radiation. Gamma radiation. We'll discuss now about gamma. So gamma rays or gamma radiation, if we look, having no charge. Is neither having positive nor negative. For that reason only it was not deflected by any magnetic or electric field. So in the category of electromagnetic wave. Electromagnetic wave which is having no effect of electric or magnetic field. Second one, if we look here, speed of gamma radiation is same as speed of light in air or vacuum. All the electromagnetic waves, that may be X-ray, gamma rays, or ultraviolet rays, infrared rays, radio waves, microwaves, cosmic rays, all are having same speed as the speed of light in air or vacuum, which is 3 into 10 to the power 8 meter per second. Ionizing power of gamma is very low because it is not having any charge. Alpha is having maximum ionizing power, then beta, then gamma. Gamma having negligible ionizing power, but penetrating power if we look, because alpha is having mass more, it is having penetrating power low. Beta is having little bit mass more, mass less in compared to alpha, penetrating power high. Now gamma having mass nearly zero. For that reason, it is having penetrating power very high. It is 10,000 times more than alpha and 100 times more than beta. And because it is not having any charge, so it is not deflected by electric or magnetic field. And here you can see, like alpha and beta, gamma also affect to photographic plate and also cause fluorescence when it will strike to fluorescent substance or fluorescence material. So photographic effect to photographic plate and effect on fluorescent material the same for alpha, beta and gamma. And it causes maximum biological damage because it is having penetrating power very high, because it can easily pass inside our skin and can pass through our a cell. Inside the cell, you can see it is having, in biology you will read, inside cell it is having nucleus, inside the nucleus again chromosome and DNA. So it can give harmful effect to the DNA structure. So it is having biological damage maximum in compared to alpha and beta. But ionizing power, if we compare, alpha is having maximum ionizing power, then beta, the last is the gamma. So this all alpha, beta and gamma, three types of radiation, and all these three types of radiation having different characteristics. Now, when a nucleus emit alpha particle, what are the changes? Here we'll discuss that nucleus, or whenever inside the nucleus number of neutron is much more than number of proton, then it emits alpha or beta, either alpha or beta. So when there is a change inside the nucleus, or when a nucleus emit alpha particle, what are the changes will occur inside? So first one, if we look here, alpha decay. Alpha particle disintegration time, it disintegrate, or when alpha particles emit, two neutrons comes out with two protons. Means because alpha is having mass number 4, means 2 proton 2 neutron, means 2 proton 2 neutron now decreased from the nucleus. So here we can say that daughter nucleus, the parents means which one emit alpha particle, and after the emission what we got, that is daughter one. So parents is having how much number of proton, nucleons, simply we can say nucleons, proton and neutron. Daughter nucleus is having number less than 4, because 2 proton 2 neutron will go. So mass number reduced by 4, because 2 proton now released, means atomic number reduced by 2, atomic number decreased by 2, and mass number reduced by or decreased by 4. Here you can see the general formula, that here the parents nucleus, in parents nucleus X, it is having A and Z. A, which is the mass number, and Z, atomic number. And daughter one, if we look here, daughter nucleus, atomic number reduced by 2 and mass number reduced by 4, A minus 4 and Z minus 2, with the emission of one alpha particle. Means when alpha particle emit from any nucleus, its mass number decreased by 4 and atomic number reduced by 2, with the emission of one alpha particle. And here, if we look, alpha particle same as the helium atom configuration. So it is having the mass number 4 and atomic number 2. And here is the one example, thorium, TH, thorium. Thorium having atomic number 90 and mass number 234. 90 atomic number, 232 mass number. So after the emission of one alpha particle, here you can see radium Rn having the atomic number 88 and mass number 228. That means 232 minus 4 will get 228. Means here this 228 is 232 minus 4, that is 88, 90 minus 2, means atomic number reduced by 2, mass number reduced by 4. Second one, if we look here, uranium. Uranium having atomic number 92, and we are taking an isotope of uranium as 238 mass number. So result after nuclear change, the daughter one we got thorium, 234 as the mass number and 90 as the atomic number, with the emission of one alpha particle. Means atomic number reduced by 2 and mass number reduced by 4. That is the effect we'll get after the emission of one alpha particle, because alpha particle having 2 neutron and 2 proton. Next one, here you can get, next one, beta particle. Means when a nucleus emit beta particle, first thing, and after the emission of beta particle, what are the changes will occur inside the nucleus? First one, what is the beta particle or beta radiation, or beta particle or beta radiation? Means beta particle means what? First thing, beta particle is fast moving electron which is coming out from neutron. So what happens in beta decay? Means when beta particle emit from the nucleus, what will happen inside the nucleus? First thing we'll see here, beta particle emission is a radioactive or nuclear change. There is no effect of any chemical change. There is no effect of oxidation, reduction, redox reaction, endothermic, exothermic, or any type of chemical change in nuclear changes, nuclear reaction. Means beta particle decay, beta particle disintegration is where nuclear change means inside the nucleus only changes will take place. Means 1 neutron, when the neutron number is more than proton number inside the nucleus, nuclear force is more than electrostatic force, then we can say here when neutron number is more than proton number inside the nucleus, it emits over 1 neutron changes to proton by emitting a fast moving electron, that is beta. And in this general formula, if we look here, 1 neutron is changing to 1 proton and 1 beta particle. Here P11 as the proton, E minus 10 is the beta particle or fast moving electron. And next one, if we look here, emission of beta particle. In beta particle emission, we can see that its mass number remaining same because 1 neutron changes to 1 proton, so there is no change inside the number of nucleons inside the nucleus. But because 1 proton number increase, so its atomic number increased by 1, or the daughter nucleus or daughter atom is kept one number right in the periodic table. So beta particle, after emitting beta particle from the nucleus, at its mass number having no effect, but its atomic number increased by 1. So here we can see one example where carbon 614 is one. Your carbon 614 by emitting one beta particle, but nitrogen 714. If we look here, 14 is same, means its mass number is same, but atomic number increased from 6 to 7. Another example, if we get here, sodium to magnesium, sodium having atomic number 11, magnesium 12, means mass number, if we look both 11, 24, that's the isotope of sodium. So 24 mass number, magnesium also having 24, means there is no change in the mass number, but atomic number increased by 1. And also after the emission of gamma radiation, there is no change of atomic number or mass number, only the parent nucleus, which is in the excited state having large amount or huge amount of energy, can release the energy to attain the stability. So there is no change of atomic number or mass number by the emission of gamma radiation. And here you can see the whenever alpha, beta, or gamma will emit from any of the radioactive substance or unstable nucleus, after some emission they will come to stability. But here one term used, radioisotopes. In my first video, wrongly I told that element whose atomic number is more than 83 is radioactive. It is actually 82. So any substance, any element which is having atomic number more than 82, they are unstable. But some elements whose atomic number is less than 82, still the isotopes are behaving like radioactive substance, means they are unstable. So that type of isotopes are in the category of radioisotopes. Means radioisotopes is the isotope of the element with atomic number less than 82, and they are continuously or spontaneously emitting radiation. In this, we are having cobalt 60, carbon 14, potassium 40, phosphorus 32, iodine 131 in that category of radioisotopes. These radioisotopes are having various use. They are used in engineering sector, they are used in the medical sector, they are used for different research. First one, if we look here, cobalt 60. Cobalt 60 is giving gamma radiation, which is used to treat cancer. Iodine 131, which is mainly the radioisotopes of iodine, is mainly used to treat the problem of goiter. And radio iron, radio iodine, and radio sodium chloride is used to trace any type of disease. as they will inject this type of radioisotopes to our body. Then after that, they will go for the different tests to know about different type of internal disease. Used in dressing, sterilized bandage. This one more easily we can sterilize to them by the help of gamma rays coming out from this unstable nucleus instead of going for the hot water. And help in nuclear reaction. Mainly nuclear reaction time we are using uranium, not any radioisotopes of this potassium, carbon, and carbon 14 is used for carbon dating process to know about the age of any fossils. And in agricultural science means for the growth of any plants or to know about the deficiency of growth of any plant, because NPK, three macronutrients for plants: nitrogen, phosphorus, and potassium. So if is there any problem due to potassium or due to phosphorus, that one also we can solve by the help of this radioisotopes. Means it is also used for luminescence sign. Luminescence means which emit their own light, and also to control the thickness of paper, plastic, or metal sheet. Means when they are preparing paper or metal sheets or plastic, to control means how much thickness they want to keep. In that time also they are taking the help of different radioisotopes. And here you can see different uses of these radioisotopes. Means radioisotopes having variety of use. And another one will get that these radioisotopes or radioactive substance, when they are emitting any type of radiation, these are harmful for our body. They are giving different harmful effect to our body, because alpha, beta, and gamma all are having harmful effect, or they are causing biological damage. Some are causing less, some causing more. Sources and harmful effect of radiation. Sources means from where we will get this all radiations. First one, if we look, radioactive fallout from a nuclear plants. Inside the nuclear plants, we are using nuclear reaction or uranium mainly used. So from that, sometime due to leakage or due to some accident, when this radioactive substance emit radiation, or the radiation will come out, that cause harmful effect to the living being, that may be plants or animal. Second one, if we look the nuclear waste. After the use, when uranium use and it is coming to a very low level, they'll not able to give a desired amount of energy. That time they'll throw, or this all become the waste. So which is coming to the garbage, which is coming to the dustbin as the nuclear waste. Or radioactive material after its use, when use is over, now very small piece, this one also can throw to the garbage. So that one nuclear waste. And nuclear waste is the main cause of nuclear pollution, which is giving harmful effect to our body. Next one, cosmic rays or X-ray. When the body exposed more to this X-ray or the rays coming from our heavenly bodies, cosmic rays, when body exposed more, it can also give different harmful effect to our body. So what are the harmful effect? These sources, when our body exposed to this, all then what will happen to us? First one, if we look, is having a short-term recovery problem. Means that type of effect which can be cured, diarrhea like, headache, minor headache. So this type of problem can easily sort out. So when we'll expose to radiation, sometime headache start, easily we can again that person can go for medical treatment and easily can be cured. But when it will come to a long-term irrecoverable effects, means due to this type of radiation, sometime like this leukemia type disease will come, which is very difficult to sort out again and very difficult to cure. Another one, the most important one, the genetic. Genetic means when the problem start from one generation and continues from one generation to another, which is the permanent one. So this type of effect or harmful effect given by radiation for that region. When we have to use radioactive substance, we have to take some preventive measure so that radiation, our body or the animals or plants should not expose towards this radiation. Or so here we'll get different different safety precaution what we'll take while using nuclear energy. So nuclear energy when we'll use, the first thing to for the setup of this nuclear reactor center. Nuclear power plants must be outside of residential area so that accidentally also that radiation will not come near the living beings. And second thing, must be housed in airtight building, strong concrete structure, because gamma radiation having penetrating power very high, it can penetrate to 30 cm of iron sheet. Means you have to give a strong concrete structure so it will not able to come out. So must be housed in an airtight chamber, strong concrete structure outside residential area, and also lead, because there is lead and steel wall. Lead having a uh, nature to absorb more radiation. So lead box we have to use, and narrow opening. More amount of radiation will come out. That is very, very difficult to control them again. It can cause destruction. So who are working the nuclear power plants, for them, what the safety measures has to take? So first one, people who are working with radioactive material or in nuclear power plants, they have to follow certain safety measure. First one, if we look here, they should put special lead line apron and lead gloves. Means gloves they have to use, apron they have to use, full apron with that, with helmet, so that they will not expose towards this radiation. They should handle the radioactive material with long lead tongue. Tongue means like this. From a distance, they have to handle this radioactive substance. They should not to touch, otherwise it will give harmful effect. In any case, no one should expose beyond the safety limit. Every radiation having a safety limit. More than that, if our body will expose, it will give harmful effect. If we look at Marie Curie, who is the discoverer of radium, first time given the concept of this radioactivity also, got Nobel for radium and polonium. So that scientist exposed more towards these radioactive substances, because of which uh, it caused harmful problem, or it caused problem to her body, and which caused death. And whenever nuclear waste coming out from any nuclear power plants in the garbage center, first thing we have to separate them and have to keep inside a lead box, tight lead box, and that lead box should have to be keep or we have to keep this all the deep soil inside, so that the radiation will not able to come out and will not give any harmful effect to our body, to animals, or to the plant. And next one here, another one radiation or another type of radiation. This one direct radiation, means we know that here uranium use, here thorium use or radium use will not go there, or will use different, will take different safety measures. But another one is the background radiation. Background radiation means what? Sometime in the garbage, very less amount of radioactive substance is there present, and that radiation which is coming out from radioactive substance is very, very low to get any other type of energy like electric energy and all. But that all can cause harmful problem to our body. Very low level of radiation at the surface of Earth is coming out from cosmic rays, from small amount of radioactive materials and rocks and atmosphere, is giving harmful effect to our body, and due to which our body or a living being can fall in different disease, or it can cause different harmful effect to the living being. Two types of background radiation usually we are having. One is internal source, where potassium 40, carbon 14, which is present in our body everywhere, every part of body having, and radium, which is found in bones. So it is giving harmful effect to our bones. And if we look the external source, in external source we are having cosmic rays, we are having solar radiation. When we exposed to this all, it can give different harmful uh, disease to our body. It can it's having effect more when gamma radiation coming out from any radioactive substance, because it's having penetrating power very high. So in this part we got about different type of radiation characteristics of alpha, beta, and gamma, and also what are the safety measures while using radioactive substance. And here also we got that alpha or beta when it will emit from a nucleus, what are the changes will takes place in mass number, atomic number. So this is our second part. In our third part, we'll discuss about different type of nuclear reaction. Means when two lighter nucleus will join together, what will happen? If one heavy nucleus break down, what are the changes will occur? This all we'll discuss in our third part. So for this, to get about the to know about the nuclear reaction, what you have to do? You have to subscribe my channel. After subscription, you have to click on the bell icon to get further notification, like, share, and also you give your comment in the comment box. Thank you. Thank you very much.